So it's getting recorded, right?
Yeah.
Yeah. So first question is like get watched videos by your friends. There are n people and each person has a unique ID which lies between 0 and -1. Now we are given the arrays watched videos and friends, where watch videos of I and friends of I contain the list of watched videos and the list of friends respectively. And level 1 of videos are all watched by videos of your friends. Level 2 will be watched by the friends of your friends and so on. So level K videos are all watched by videos of people with the shortest path exactly equal to key. So you'll be given the ID and the level of videos and supposed to return the videos ordered by their frequency. So here if you look, so the friend of 0 is 1 and 2. Friend of 1 is 0 and 3. So in this diagram, 0's friend is 1 and 2. 1's 0, 3 and 2's is 0 and 3. And for 3, 1 and 2. And ID they have given as 0 and level as 1. So 0's direct friends are 1 and 2. And the movie watched by 1 is C. And movie watched by by 2 is BC. So the frequency of C is 2 and B is 1. So we have to sort it in a increasing order. So B will come first and C will go second. And similarly here, you can see they have given ID as 0 and level as 2. So level as 2 means 3 and 3 is watching the movie D. So there is only one thing. So D is the answer here. Yeah. So what would be the brute force over here in this one?
Oh, yeah. So we have to go K levels deep, right?
Yeah.
Okay. I mean, it looks to me as a BFS approach.
Okay. Yeah. And after that, what, like once you get the friends at level 1, you will check which all movies are watched by them, right?
Yeah, which is at that level by BFS when we reach that level, and by BFS and all the neighbors at that level, we will be finding videos and over there, over the index which we have at that level.
Yeah. And then sort it according to the frequency in increasing order, right?
Yes, frequency increasing order, and then based on lexicographical order.
Yeah, if they are similar in frequency, I mean same.
Yes.
Yeah. So you want to share the code? Like,
I can share it. Just give me a second.
Yeah, so can we actually describe this on a whiteboard or something like that? Because is it like just the level what we have to go is like each and every level we have the straight friends list, or it's something like can we have to create an adjacency list before going there?
yeah, sure. So let me. So this is for zero's friends is 1 and 2. One's friend is 0 and 3.
Mm-hmm.
And two's friend is 0 and 3. So this is our 0. So his friend are 1 and 2. And one's friend is 0 and 3. And two's friend is 0 and then 3. And three's friend is 1 and 2. Yeah, this one, these two. Now they are telling ID 0. So ID 0 is this, I mean 0. And their friend, and they are telling to the level 1. And 0th friend is 1 and 2. So these two are the friends of 0. And the movies watched by 1. So this is movie watched by 0, movie watched by 1, movie watched by 2, and movie watched by 3.
Mm-hmm.
So 1 is watching the movie C and 2 is watching the movie BC. So C is occurring 2 times and B is occurring 1 time. So we are just sorting it in an increasing order, so B and C. And had the frequency been same, then lexicographical order, like first B followed by C.
Correct.
Yeah.
Yeah, but when you are actually going to next level, so you go pick up those um, indexes of a particular ID, right?
Yeah.
And then you actually go and find what the next level will be. So
Yeah.
so are we going to first create adjacency list for all of them, or?
Yeah, so we can create a map with index and all the neighbors. So that would be like, so as you can see in the friends list, index would be like zeroth index would be our key, and the neighbors would be all those, the value in that index. So,
Okay.
and so if, and that would be like a map, or you can create anything. And so this seems to be like, so as you can see here, this would be like zero would be our key, and ID would be our value, or like this in a
We
map.
already have a 2D vector. I don't
Oh,
think
okay. I think we already have adjacency list, right?
Yeah, this is already there, or you can just go to at that index and find get that value, or you can create a map. I have created a map for mine. So and we have given this ID, so we'll be starting from that ID like zero, and by BFS we'll take that value, this value, and traverse those, and we'll need to take a visited or something, because if we are in some other level and that would also be visited, already visited will not be visited again, like proper BFS.
Correct.
So
And when you actually are going to reorder them, when you return the output, how are you going to get the frequencies of the videos watched?
Dictionary you have
so
to get
yeah,
again.
so yeah, that is like I've created something like a map that would be storing those count of these values. For example, C would be 2 and B would be 1. So these would be the, uh, and we can sort on the basis of the frequency count. And
Okay.
then, yeah,
Okay. Makes sense.
yes.
Yeah, sure. Got it.
Uh, I can share.
Uh, yeah. In the above example, if the level is 3, is that a valid one?
No, only level 2 you can have, right? Zero
Uh,
first one.
uh, why, why can't be? Like from first will be 1, 2, second level will be 3, and again we go back to 1, 2. It should be valid, right? Like
that
maybe
is a
we
good
So
go
that
back.
would be, so that
that
would based on the index. If your index is 3 and you are pointing that as a, so so that would be like, and if you can go like this, starting from 3, if you can go like this, I think then it would be possible that 1, 2 is again level 1.
I think there's a very important line in the question that we have missed. So it says that K has to be the shortest path from the ID.
Okay. Yeah.
Yes.
So, for example, if I join 0 and 3, and if you ask me uh, uh, for the level 1, 2, 3, so that there might be an argument that 0 can be a friend. But since the shortest path for 0 to 0 is 0 only, so we won't consider it for K equal to 3.
Your direct friends they are telling.
Yeah,
Your direct friends will be shortest path only, right?
yeah. So as Dilip was saying that because 1 and 2 are friends of 3, and if
Okay.
you like take them as another level, like consider 3 and 1, 2 as the another level. So in that case, I think I also thought that, but the shortest path from 0 to 1 and 2 is 1 only. So we won't consider that.
Yeah, in that case, then. But
I didn't get the so you are saying that will not be considering the path
So,
from 0 to 3?
who is sharing? Sonia, are you sharing?
Yeah, I'm sharing.
So, can you just make a child of 3?
Okay, 1 second. I'll take a pen. So child of 3 is 1 and 2.
Yeah, just in the diagram only, like make another child 4.
Okay.
Yeah, and connect this 0 also.
Hmm.
So, I mean, if you go by the BFS and if the k is 3, then there might be an argument that 4 can be the required friend, right?
How many levels are there? This is 1 level, this is 0 level, this is 1 level, and this is 2 level. So
Yeah,
levels are
Yeah, I think here the levels are only 3 here.
Yeah, I think I'm not getting the right example.
Yeah. So I think, yeah, if we have level 3 or 4, I think it should be fine, right? Why not?
it should be like this. Either to get another level, it like this is how it reached, like 3
Yeah,
to
but
4 or
yeah,
something.
it has to be unvisited node.
Yeah.
Yes.
Okay, so let's ask Dilip, because he brought up this question. He might have some point. So
No, I
what?
just got the doubt. When I'm trying to solve this problem, so I thought like it's just if we don't consider that way, it's a straightforward BFS, and then we try to find a frequency. I thought maybe it's the complex problem was if we can see this way, find all the paths, and if the levels are more than the length of the path, then we can kind of modulate and see until where we get, and only traverse up to that point.
Right. See, what I see is like the example 1 and example 2, we have only 3 levels, 0, 1, 2, right?
Yeah.
So
Yeah.
if you would have had an example which had 4 and 5, then I think it should not be a problem to go there also, right? Because it's just a straightforward BFS which is having friends as an adjacency list. So you can have many adjacency lists, correct?
Yeah.
So if the graph is bigger, why not we can go for the next level?
Yeah.
That is what
And
my thought
also,
was. Maybe I'm wrong, but I'm just
yeah.
trying to brainstorm here.
So, but the only question is you will be giving the ID, and the level would be start counting from there. For example, if you have given the ID 3, and then level they'll be saying 1. So we'll be counting this as a level 0, and the next neighbors would be 1, level plus 1, because we need to go uh, like friends of friends or something like that. If they it will be saying like level 2, then we'll be going from 3 to 1 and then to 0, and ID if we have given the ID 3.
Yeah, but they can be nodes in multiples level also, right?
Yeah,
So
we
it's
can have more
Yes.
nodes.
join 0 and 4.
Yeah, similarly, ones would be 3 and 0 children.
Yeah, so if you join 0 and 4, then you can say that 4 is in the level 2 also and 3 also. This 4 only, which you have made.
This 4 would
But
be the
If you join 0 and 4,
they are direct friends here.
yeah, so
okay.
they can 4 can also be said to be in level 3 or 2.
Level 2 it will be.
Yeah.
So if 4 is there and I have directed over here.
Because it is a direct friend, so it is at level 2. I mean, it depends on index level. Yeah, level 2. Like
So
1, 2, and
0
4 are in
children
the
would be 1, 2, and 4 over here.
yeah.
Yeah.
So this is level 1 only. Like,
Yeah, this would
Only
be level 1.
the unvisited nodes at the level k that are all we need.
Yeah. Here there are a lot of cycles, right? If we had a tree type of a graph, like 1, 2, 3 trees, and we have different levels. So then I think that should be fine, because then we won't have this complex, what do you say, relationship. we had like 0 just pointing to 1 and 2, and then 1 and 2 we have another left and right, and again left and right. Okay, if we start from 0, we just consider we have to always start from 0 level, 0 index, and then go n number of levels. So that should be fine, right? They have never mentioned that it should be a graph.
Yeah.
So another real life example that I can relate this to is LinkedIn. Like in LinkedIn, there is something like first connection, second connection. This level is actually the same thing, right? So if two persons are, if in LinkedIn, if you are taking a person and if it is shown that he is second connection, that means that the level is 2. So we can relate it to that, right?
The
Yeah,
mutual
right,
friend,
right.
friend of friend, yeah.
Yeah, actually, the friends you cannot go more than certain levels, right? Because it doesn't make sense. Yeah. So that also might be a case. Yeah, Daniel,
Even
I
constraint,
think that is correct. Yeah.
yeah, even in constraints, it's given that the length can be maximum n, where n is the length of friends. Like it can't be the n, it can't be n, it should be less than n.
Yeah, the level they say are I think 100, level is 1 to almost 100.
Yeah.
So you can start from 2, at least you have to have 2 levels because you will start with yourself and you'll have some friends. So 1 and 2,
Yeah.
something like that. Yeah.
Yeah.
So it should be possible because they have given the constraints also. Only the examples what they have represented, they have just level 2, and which seems to be appropriate, right? The way Daniel says the application could be a LinkedIn, then this makes more sense. Yeah. Yeah. So therefore, not going more than level 2 is because it's not a practical, feasible solution, something like that, and therefore they are just
Yeah.
come to level 2. Yeah. Right.
Actually, who is sharing? Can you try and give an example? I mean, definitely it's not the case, but let's try what it is.
So maybe another example will be like 0 is having just one friend, that is 1. 1 is having only one friend, 2. 2 is having one friend, 3. Like it will be a singly linked list.
Yeah.
0, 1, 2, 3, 4. So in that case, if someone can draw it, it will be easy, I think. So
Yeah,
like
I
in
You
mean,
that
can use
case,
annotator.
the
Annotator you can use.
can I use? Oh, okay, got it. Hmm. Can you see?
where you are.
Sonia can
On
clear
the
the screen.
Okay.
I tried giving the same input with level 3, and it gives an empty. So I think
yeah,
I
because there is no. Can you see this? Yeah, okay. I think you are drawing, right? Yeah, fine.
I am drawing a. Are you drawing? Yeah, we can see it.
Okay. Which one are you able to see?
That
The
blue.
numbers. Yeah, the blue one. Yeah.
Okay, the new one, right? Okay, fine. Sorry, it's difficult for I'm using trackpad. So I hope it is clear. 0, 1, 2, 3, 4.
Yeah.
So in this case, if ID is 0 and if the level is 3, the only person will be 3.
Yep, I think so.
Yeah.
So you can
Yeah.
just go and find the videos of 3 and then return it. Correct.
Yeah. So this will be a good example, I think. So the maximum will be the number of friends minus 1, maximum level.
Yeah. Yep, cool. That's good. Thank you. Yeah, Sonia, could you walk through that example, the code?
Sure. Let me clear the train.
Oh, sure. Yeah.
Yeah, I'm clearing.
Yeah, I cleared it.
Yeah.
So actually, I've created a map of these neighbors, which is not necessary, but if you want to use that as it is, they can use that as it is as well. I've created a visited set and added a ID which they have given, which is like 0, and created a queue and appended it that ID. And to reach that level, I've created count. So I'm creating a normal level order, and so I've created a size, and if my count is reached to that level, I'll break that my loop. And further that I am until unless this is normal level order, this is like size is greater than 0, I am popping out my first node, visiting all the neighbors of it, and if it is not in a visited, I'll append that and append in a queue and also mark that visited, and then size -1. So when I am out of this size, like this level is completed, I'll be my count will increase and I'll reach to this level. As soon as I reach to this level, so it means that I have all the neighbors which I want of that level, and then I'll break. And so then I have created like get videos. So whatever left in a queue, I pop out all the I traverse that queue and I popping out these elements in a queue, and that element index I'm fetching from that element index. I'm fetching the videos which they use, and for that I've created a frequency count map to put that in my map to create that how many times that video has been seen. So like this, it would be created my map, and then I just sorted on the basis of this frequency, and then key, which would be my video, and rest is like just appended my key in the result and just return that result over here.
Yeah, makes sense. So it's a straightforward BFS solution.
Yes.
Yeah, we just have to take the levels and then get the videos and then sort them. Okay.
Yeah,
based on the frequency. Yeah.
Yes, based on the frequency and this, because I see when I didn't sort on the basis of this key, I got one or two errors. My test was not passed because in that test case, everything was frequency count was 1.
Oh, okay. Yeah.
So you need this as well.
Yeah.
Any questions? So this is an extra space I've created, but which is not required. So this can be neglected. Just use it as it is. And rest is like a BFS, which is order of V plus E. What this is like nodes plus edges, that complexity. And yeah, here we need a map. And yes, and this is a sorting, which is worst case n log n. And so this would be like overall
E and log n for that.
Overall n log n or order of V plus E.
I think it should be V plus E, because when you go to any level, you are not going to have all of those indexes, right? All of the friends.
Okay, yes.
Right.
Yeah.
So you'll have only few of them, a subset of it.
Mm-hmm.
And then you will get those videos from them.
Mm-hmm.
So it will be a subset, whatever the subset, if we call that as an M, so M log M in that case, but it will be still lesser than V, correct?
Yeah.
Yeah, overall it is order of V plus E because we always take the big O.
Right.
So this is a subset. Yes, it is correct that M log M is a part of an order of V plus E. You can say. So yeah, order of V plus E.
I think in in the worst case, if there are n minus one nodes at the level we are searching, then I think it would be O of V plus E log E. So in this example only, if we have three at my level one only, and if my k is one, then in my I'll be sorting three nodes, 1, 2, 3.
Yeah, but that again will turn out to be order of V plus E only, right?
So are you sorting the nodes in the level k only, right?
Yeah.
So if on my level k I have n minus one nodes,
Okay.
so then that would be uh, uh, the order of edges only, right?
Mm, and minus your order of edges only. I mean,
But
minus
that's
one.
already that's already like we have created a picture of the overall V plus E. So rest is a part of those.
Yeah.
Which
So that will be like, okay. In that case, okay, you can have any number, right? Oh, yeah. So
right.
you can have a single one in level index 1, index 0, and then you can have many of those in that.
All the
Okay.
rest of the friends at my k level.
Yeah, because it's not a binary tree, so it's a graph. Hmm.
So if 3 is at the level of 1, 2 only, then I would have 3 nodes at my level 1.
Okay, but in that case, we are saying like if it's a graph, the big O will be V plus E, correct? So in that case, if E is a dominant factor instead of the subset, so there we can say that is a special case. Maybe it's V plus E log E, something like that.
Yeah. So
Maybe
for the
something.
example I said, it would be O of V plus E log E.
Yeah. So, but
That
that will be a special case in case if the numbers are great, right? Yeah. But for average
Worst.
case, it should be V plus E, correct?
Yeah, yeah.
Oh.
But
But
he's telling for the worst case, I think.
yeah, that is true. But we can always say average it will be this way, and then in worst case we can explain an example. In that case, it will be V plus E log V, E log E.
Yeah.
Right, Arjun?
yeah, absolutely.
Okay. Yeah, good. That's a good thing you brought. But I think that's the only thing way I would do, the way Sonia did. Correct.
Yeah,
I don't think so. There is any optimizations which I could think of. Only instead of using a sorted on a map, I would use something like a priority queue.
yeah, I was
Yeah,
yeah, that's also a point. Yeah,
right.
that can be. Uh,
But that's not an optimization. It's the same thing.
yeah. So yeah, Protein can be made on the basis of these two comparator as well. Yes,
Yeah.
it can be done.
Yeah,
Okay,
we can have the DFS also, but that would be not this optimal.
so it's so the only thing is it's mentioned over here that minimum path
Right.
something
And the level thing.
Yeah, therefore
and
we
the levels
always tend to come to BFS. Yeah.
and the levels also. So that would be like BFS and level order combination of it.
And that makes sense because if we do DFS, then we'll have to traverse the entire graph. Here we are just stopping at the level k.
Mhm. Mhm. Yeah. Okay.
Yeah,
Yeah.
thank you.
Thank you.
Yeah.
Yeah. So our next problem is increasing subsequences. So they have given an integer array, and our task is to find different possible increasing subsequence of the given array. and the length should be at least 2. So for this, I mean 6 greater than 4, 7 greater than 4, again 4, 6, 7, all these are the increasing subsequences. Your array length will not exceed 15, and range of integer will be in this, and it may contain duplicates also. And 2 equal integers will also be considered as a special case of increasing sequence. Yeah. So what would be the brute force? Okay, go ahead.
What does this line mean? The last line in the constraint.
Like this case will also be one of the increasing subsequence.
Okay.
Yeah.
So the brute force would be like start with 2 nested loops, right? To
Okay.
start from the first one, take each and every index, start with the first index, and in the second loop, you try to find whichever is a greater element than the first one.
Previous element, yeah.
Previous element,
Yeah.
correct.
Yeah.
And then whenever you find there is something greater, then you just form a pair or whatever, an array, and then you push that in your result array. Okay, and then keep on incrementing. So in this case, it's 4, 6, 7, 7. So I'll start a loop from 4. The outer loop will start from 4. The inner will start from 6. So 4, 6 is greater. So 4, 6 will first go inside. Then my previous will be 6. Then I'll compare with the 7. So 4, 6, 7 will be another one. Correct.
Yeah.
And then for the another 4, 6, 7,
So,
7.
Yeah, but I think you will miss on like if for the example you were saying, how will you take care of 4, 7?
Yeah.
Yeah. So what
Correct.
we can do is like we can store the previous results, and whatever we are getting when we compare it with the last one, we can add that result also.
Okay, so you are saying like store the 4 as well as 4, 6, correct?
Yeah.
And then when you compare 7 with 4, you see if 7 is greater than 4, you add that to the first one as well as to the 4, 6, 7. Okay.
Yeah.
again, you keep this result, and next time again 7 can be
Yeah.
appended to.
Along with the current result, I mean previous result, we'll add the whatever element we are appending, we'll add that set also, I mean that list also into our result.
Mm.
Yeah.
Yeah.
Yeah, or otherwise it's like a subsequence problem we can pick, or I mean just move on that way also.
Yeah, here we'll be checking, right? Like
Yeah.
if the element which we are taking, whether it is greater than the previous element or not.
Right. When we are
So
picking,
that condition must be there in every iteration, right?
Yeah. Yep. When we are trying to pick an element, we have to check the last.
Yeah.
It's like a subset problem. Like times Uday was telling me.
Subsequence.
Yeah.
No, this is subsequence. Like the way what you are telling. Earlier we had a subset problem in which like we used to store first subset with single element and then append. Do you remember
Yeah,
like
the
approach.
Correct.
Yes,
Correct,
all the subset and subset 1, subset 2.
exactly.
Yeah, those kind of a problem. The only condition over here is that you need to make a subset of which is increasing in an increasing way.
And
So-
there we were allowed to.
Additional
We were not
parameter.
allowed to keep duplicates. Here duplicates are allowed.
No, in
Yeah,
some
that's the
cases they are
difference.
allowed duplicates as well, I suppose.
Yeah. Right.
Yeah.
But does this problem specifically say that we have to, yeah, it shows as per the example, but have they said something in the constraint about duplicates?
Yeah.
Yeah.
Okay. Okay, makes sense. No problem.
Yes.
So what would be, yeah, this will be a sort of brute force, but if we have to think about some optimized way.
No, I think
So
that's
the-
also optimized one. What you were saying.
Okay, yeah.
I think we'll have to visit all the subsequences. So the brute force would be the solution, I believe.
So in the normal subset sequence, we always use that particular kind of a backtracking approach format, where we add those values in a temporary list, and then after it has been done, then we pop the last element.
Which how?
So let me check that. So, for example, when we add 4, we will go to 6, and then again we'll go. As soon as we make a condition that if our subset there is one, then we should have at least 2 subsequence. So as soon as we get this kind of a subset, we add that in our result set. So this would be added in our result set like this. For example, this is our result set and this is added. But we already having this 4, 6 is going on. So next we'll move ahead and add 7. And this is also greater than 3. So we'll add 4, 6, 7 over here in the result set. Then again 7, then we'll add 7 over here, and then 7. As soon as we reach out of this, we'll be start popping out this 7. And we need to create this list as a kind of a set so that it cannot be repeated.
Yeah, duplicate shouldn't be.
Okay.
So yeah, duplicates, because we are popping out. So this will be popped out, this will be popped out, and this will be popped out. So in the earlier, in this is a DFS, like a backtracking. So this would now our index would move ahead and it will go to 6. Earlier our index was 4, and now it will go to 6, and again it would start from 6, 7, and that would be also added.
Oh, okay.
So
Got your
yeah,
point.
so it's like how we go with the backtracking approach. Like first of all, the only thing is like we need to pop out the elements, and we need when we get that kind of a list, something which is greater than 2 or equal to 2, we'll check if that list is already in our set or not. Then if it is not, we'll create, because it's a what it is called, list is type of a, we cannot create again.
Right. So you don't have to have a duplicates, right?
Yes. So we just need to add that.
Yeah.
We need to create that list at that point as a new array list or something, and then add it over here.
Yeah, that's would be a good approach. But my only concern in that approach is you won't be able to maintain order the way they are maintaining here. I'm not sure whether we have to
Yes.
maintain an order. That was my question.
I don't think so. It is required to maintain an order,
Mhm.
because it's a subsets, and subsets there is no required.
Yeah, because they are also showing like 477, which is the last one. So it doesn't make
Yes.
sense. There is no order as such.
Order,
Yeah.
Yeah.
Okay. Yeah, that also should work then. It will be a recurrence relationship the way we do for the dynamic programming from the top-down approach, right? We can do that way, right?
Yeah, depending. Only condition will be at which point of time will you append the result to your answer. I mean, the array to your.
Oh yeah, we have to append also. Yeah, that's something very different. Yeah, won't be a DP though. Yeah.
Yeah, somewhat like kind of.
Yeah, that's good.
Wants to share the code.
I don't think so. She has coded. She was just thinking loud, right, Sonia?
Oh.
No, I have coded it.
Oh, okay. Then let's go for it. Yeah.
Okay, can you see my screen?
Yeah.
Okay. So this is a null check. I've created a result set, which is a type of a set. And this is the main, like you can say backtracking or DFS approach. This, I can say this is a backtracking. So as you can see, if my exit condition, if my length of my numbers is greater than that of index, and like this is true, like index is like one is starting from 0, and the result set is greater than equal to 2, and I'm checking that if that the list temporary which I have created is not in my result, I add that in. And here my loop starts, which will start from that particular index which I passed till the size of my numbers list, and it will loop only when this is true, and this is like if my previous element in my list is lesser than the current element which I am doing, like because we need to add only the increasing subsequence, so that's why this condition is required. And before I add that my in a temp list, which is before that it was empty, I added my current like 4 here, I added 4 over here, and then I again call this function with I plus 1. Now my I plus 1 is at 6.6, element 6 would be there, and this list would be, temp list would be like this 4, which includes 4, and so this would call, and still it is not, length is equal to 2, then it will go over here, it will start from 6, and it will check it is not, my list is not there, so it append over 6, it's append 6 over here, and so this so next is like I plus 1, which will go to 7, and this will go over here, and it will check this list is completed, so this would add 4 6 over here, and this will return over here, and no, so
You are not returning there, yeah.
no, I'm not returning, sorry. So this will again go over here, and the index was our at 7 points, so it will add 7 over here, and it will this would be this 7, which is index 3, and here it would add 4 6 7, yeah, this, and then again it will be at 7, this would add 7 over here, and here it would add this full list, and so now it is not so now it is index is not greater than that, it will come back over here, and it will pop this particular element. So this is like if it is popped that element, then it will traverse again with where it was last at that index. Still it is not, still it will not add that, so it will again pop this. So again it will not add that, it will pop this, and so this
That
will
will go to
also
7, yeah.
Yeah, it will go to 6, this next index.
I think it will go to 4. 4 will still be there. Instead of 6, it will go for 7. Then in that case, 4 and 7, right?
Yeah.
Oh
4
yeah,
and 7.
4
yeah,
and
yeah.
7. Sorry, yeah. So this was pending. Yes.
Right.
This traversal was pending. It will go to 4 7.
4 7, yeah.
And 4 7 would be added over this over here. And again 4 7 7 would add it, and this would be over here. So next is this would pop out, and so but we can't add this 4 7 was already in a set. It will go to this index, but it is already added in that part. so it will not be added in our result set.
Right.
So this loop is over. So we'll go to that next index, which is 6.
Yeah.
And it will again go over here, and it will add 7 over here, which is 6, 7.
Yeah.
And then again 6, 7, 7.
Yeah. So that's the end, and then again you'll pop.
So that's an end, and it will popped out, and it will goes to next 7, but 6, 7 is already in our list, so it will not be added. So it will go to 7, and so 7 single cannot be added. 7, 7 is our one of the list which need to be added.
Yeah.
And
Yeah.
that would be our
End.
end. Yes.
Yeah. So, but then when you did this, what was the time as per lead code? Just curious, Was it the most efficient one? Oh
It's,
yeah, you got a very good one.
yeah, it's 236.
Hmm.
Because this is the template which I follow in the subsets also. There is, if you can see those templates, you can solve like questions of combinations, subsets, all these which require some kind of this subsets or something, or permutations.
Yeah.
So that template is this is also the same part.
Okay.
Yeah, this is good. Because the way
Very
I
good,
solved,
yeah.
I was using that normal recursion, and I had to make another vector for the second call. Here you can simply pop and reuse that vector.
Yeah, just need to pop the last element over here.
Yeah, that's.
So Harshit, you are saying you are using an additional space, right?
Yeah.
But your time complexity is slightly better, or how is that?
So time complexity would be same, but my space complexity would be a bit, inefficient in this.
But
So
you
in
are
this,
following the DFS?
Sorry?
Are you following that DFS as well?
the recursive way.
I'm for, yeah. So yeah, kind of. I'm just picking or not picking that way.
Oh, either of the two cases, yes.
Yeah, because the way Sonia is doing, because she is always going for each and every element, right, in the recursion. So I thought it might take more time complexity than going through a iterative way, So
But
therefore I was.
But I think that is a part of the process, right? Because we have to explore all the subsets.
Mm-hmm.
The standard backtrack, yeah.
Yeah,
Yes.
you still have to go. Okay. That will be the.
Here would also be high, not low, because we are like how we were iterating, we are traversing all the paths. Here also, like we are traversing every path.
Yeah, that we have to. Yeah. The constraint is also less.
So this is complexity wise, I would say something exponential would be there.
Yeah.
2 power n, I think. 2 power n.
Sorry?
2 power n.
So two
Length
is
of the list.
by 2.
Because if you visualize this whole process, for each element you take 2 paths, like selecting 4 and not selecting 4, and then based on that, then you can have other 2 paths for the next 6.
So that is brute force, what you are saying, right?
Sorry. Yeah.
That is brute force, what you are saying, that either element can come or it can't come. So
yeah, even Sonia is doing the same thing, right? Like
yeah, even here is also the same
path.
thing that would be added or not. So yeah, that's correct. 2 raised power n would be.
Yeah.
And
Sonia,
n is, sorry? I think someone is. Can we make on mute? Yeah.
Yeah, everyone went on mute. Okay. So actually what Dilip was saying is like, you can go for every time and then you have two options, right? Therefore, it's going to be 2 raised to n, which is exponential, correct?
Yeah, and n is the input size.
But I am not sure why we have only two options here.
Yeah, two options only, right? Either you can take or you can't.
Yeah, but that usually happens when you have something like a knapsack, right? Whether either you take it
Yeah.
or you don't.
But here also you are checking here, no, whether if the current number is greater than my previous, then only I'll take, or else I won't take.
But that you're just adding in that is for the line 20 and 22, right? 20, 21.
Yeah,
But you're
that is the
still
main.
traversing.
Yeah, we are traversing.
We are traversing each and every path for each and every element.
No,
So it's still
that's
exponential, but I didn't understand how it is 2 raised to n.
So,
2 raised to n will like
because when we are traversing, like for example, 4, 6, if for example over here some element would be 3, so that's the case we'll not be taking. So that's just like we are checking whether we take or not. And we do so we are though making so the other one was I have created that 4 7 which was duplicated again. I have traversed that path, but at the end I checked that I can't add that because I've already had that. So I'm backward. I've didn't add that, and I traverse back. But yes, that was selected. So I choose that. But it is not added in a result set. That's a separate thing. So that means like we are adding those elements each and every time.
or if you make a tree and we calculate the height of that tree, recursion tree, and the number of nodes at each level,
Would you try
that
that?
would be the. No, I'm just guessing for calculating the time. I mean, backtracking problem it is no. So it will form a tree. So number of
Yes.
nodes at each level and what is the height of a tree. So height of tree will be like log n, right? Or worst case, it would be order of n.
Order of n would be sure.
Yeah, it
Height
would be
would be
order
n.
of n. Yeah. It won't
No,
be
balanced tree will be log n, and worst case will be order of n.
But I mean, we're not kind of maintaining any balance tree, right? We'll be going into the entire nums array, so that would be n.
Yeah, I was feeling like best case if yeah, that's true. I mean, it will be order of n only. Yeah.
Yeah.
And number of nodes if you calculate at each level.
Yeah. Every time we are spawning two branches.
No, it's yeah.
Yeah,
Only
that's the
two.
thing I'm not getting. When we say we are spawning two branches,
It can be more than
I
two,
think
right?
yeah, it can be more than, yeah.
I think
So
the
we can
backtracking
either
code. Yeah, Randy, go.
select or not select, right? Then there will be only two branches, right?
No. Branches can be more than two. I mean, it will be like n minus one at every node. Like, I mean,
No, branches would be
Actually,
more. Node.
if you have three, if this is let's say 4, 6, 7 is there. 4, 6, 7, 7. So let's say somebody selected 4, and he started and did something and then backtracked. Next time I'll select somebody will select 6 and he will do all the further operations and backtrack. Somebody will select 7.
Okay.
So at every level you have node like, I mean, like n, and again his children will increase. So that will again
Yeah. So,
be bigger. So it will be
so
two, right?
it's difficult to kind of show this backtracking code using the tree. So it's the same like the way we do in DP. That so what Sonia is doing is she's going down one path completely and then coming back and going to the right branch.
Yeah.
Oh, yeah, okay. Then next time she'll take 6, right?
So it's yeah. If you are
So one at a
excluding,
time is okay. Go ahead.
yeah, you're right.
It's like backtrack. So backtracking complexity will be.
No, but Santosh was telling right, like it's not. I mean, only can't have only two options.
I think I'll quickly share my code. That is exactly what that branching approach is.
Yeah, sure.
Okay. Yeah, thanks, Sonia.
And,
Yeah,
and
yeah, Dilip,
Shashank,
go ahead.
you said you gave an example like selecting 4 or 6 directly or 7 directly. All those selections will come towards the left and somewhere to the right of the same tree. You will not have more than two childs of the 4.
Yeah. These are the two calls. One we are taking and one we are ignoring.
Oh, okay. So you did it this way. Okay.
Yeah, but this is inefficient because I am using this. Oh, is it? Because no, I'm using this array. Yeah. I'm using this res array for this call, and I'm making another vector for this call. So this was not what Sonia was doing. She was using the same array.
Okay, so you're adding the current one and using that current for the next upcoming one, right?
Right.
Now that explains why Dilip says 2 raised to n. So that also, Sonia's approach will also have the same time complexity, even though
And
it's
yeah,
implemented
one
differently.
more thing.
Yeah.
It's not 2 to the power n. It would be 2 to the power n into log of 2 to the power n, because we are maintaining this this set also. This for the sorted sequence.
Okay.
So it would be log of 2n. That would be n. So n into 2 to the power n.
Yeah, n into 2 to the power n would be the correct, I think.
We missed out on this part.
Power.
Harshit, actually, why are you creating extra vector? You can pass the same vector and then pop the element from that vector and then pass the same to the next helper function, right?
Yeah, right.
So it's like
You're right.
Sonia's.
Yeah. But
could have-
Sonia is calling once. He's calling twice. So you can call the helper function which is not adding the index element first, then add the element and push it. Call the next helper function.
Right, got you.
Then
I
it
could
would
have.
be raised to power n only.
Sorry.
Why it should be log of 2 to the power n?
Yeah, so why it should be log 2 raised to power n then?
Because we are maintaining this set, no, this thing. This. So to avoid this duplicate thing.
That would become in a space complexity, no?
Yeah, so that is what I'm. Oh, no. But this map is essentially a sorted sequence, right?
Yeah, the map is a balanced tree. Yeah.
Yeah. So
Behavior.
every insertion is a log of height operation. So in the
Okay.
worst case, we'll have these 2 to the power n number of subsequences, and this would be this. So it would be n. So 2 to the power n into.
So in my case, I have
Yeah, go on.
I got it, yeah.
I took that as a set and checking in a set, it is like an order of 1 operation.
Are you using an unordered set?
They have an unordered set, right? Python
Yeah,
and
it is
Java.
an order, yes.
Yeah.
Python have only one set, like normal one.
Yeah, even Python has only one set, correct.
Yeah. So therefore, we should not, we could also do it without using a map here, like an unordered map.
Right.
Yeah.
Right. Yeah, in that case, then
I was facing this problem. Are we not allowed to have vector as a key in this unordered map?
vector as a key.
Yeah.
Oh.
Yeah, you can, I guess.
I mean, I first used that unordered map only, but I was not able to. I mean, I was getting some error, so I just quickly moved.
Okay, yeah, there are some things about unordered map very different. So maybe use
Maybe
an
you
int
should
and
not
vector.
store it as a list, instead some tuple or something.
Yeah, that's why even in my case as well, I took a set and I was storing as a list, creating a new list and storing in a set. So it was not able. I was not able to add that. So I used tuple in that case to add that in.
So use an unordered set in this case, and that might be.
Even unordered sets are implemented using some kind of tree, right? It's not.
Those are hash tables.
Hash table, yeah.
You cannot hash a
So
vector. That is
one.
why you can't use unordered map. Right. I also thought that we cannot hash a vector.
We cannot hash a
So one
vector. Then
question,
use a
Harshit.
key. Mhm.
Yeah.
So this log of 2 power n is for the set, right?
Yeah, that's for my code only. I think Sonia is handling it differently.
Yeah.
Yeah.
I have done in an iterative way, maybe.
Okay.
Yeah.
Right.
Yeah. So Harshit, yours is almost like a knapsack sort of, right? So
Yeah.
yeah. So 2 raised to n actually, it's very clear in that case, right? It's very evident the way it is implemented. But Sonia was slightly hidden, so you could not make it out the 2 raised to n.
Yeah.
But yeah, but
I
both
could have
are
also
the
done
same.
that. Yeah, I could have also used, as Dilip pointed out correctly, I could have just popped out that element and then use that vector again.
Yeah, then you would have avoided the space complexity. Okay, good.
Right. Yeah.
Yeah, go ahead, Navin.
Yeah, so there's another approach which I'm just thinking of, which I haven't fully implemented, but I feel like that it could be optimized. So if we can.
Let's finish with Nandini and then we'll go with the Abhi. Okay.
Okay.
Yeah, same thing. Like the method is same, but I have done an iterative way. So if the set is empty, I'm just returning it, or else what I'm doing is this is my result set. For that, what I'm adding is the first element. So result set will initially have 4. And then what I'm doing is iterating this for loop is from 6 to rest of the elements, and the next for loop is for the list elements. So let me take an example, like initially my result, this result will have 4, and I'm iterating from 6. So what I will be having is I'll be checking this result set, whether the last element, that is 4, is greater than the current element, that is 6. So as 6 is greater than 4, what I am doing is I am adding that along with, along with this 4, this list, the 6 is also adding, then it will become like 4 comma 6. So this whole set I'm appending it to the result, so I'll have something like 4 comma 6. And one more step which I'm doing is I'm appending the 6 alone also. So in the so I'll have in the first iteration of the for loop, I'll have 4 comma 6 and 6, and then my coming element is 7. So when 7 comes up, I will check all these 3 sets last element, whether this 7 is greater or not. So here we'll be having 4 comma 6 and 6. So 7 I'll be comparing with 4, 6, again 6. So if as 7 is greater, I'll just be adding 4 comma 7. I'm comparing this internal for loop. I'll be checking the last element with the outer for loop number which is coming up. So as 7 is greater, I'll just be adding that particular number. Along with that, I'm adding the element alone. This step will have only 7. So these all results, I'll be adding it to my result. And then what I'll be doing is, so in the next iteration, I'll be having all these elements. The next coming element is again 7. So I'll be comparing the last element, that is 4 is greater than 7. As it is greater, I'll be adding this 7, and 6 and 7 I'll be comparing. As 7 is greater, as it is forming increasing subsequence, I'm adding it again 7 like this. So 7 again, here also I can add it, because greater than or equal to, here 7, and again 7 comma 7.
Yeah.
Along with that, this line, so along with
Yeah,
that, I'll be adding extra 7 also. So my final list will consist of rest will consist of all these elements, all these sets. And then what I'm doing is I'm taking each and every element and calculating the length of it. If it is greater than or equal to 2, then I'm keeping it. If not, I'm discarding it. This is the line number 14. And in Python we can't so I have to eliminate the duplicate sets, right?
Right.
So for that we can't do it with the list. So what I'm doing is converting it into the tuple and checking whether it's already exists or not. So here finally I'm taking set, which gives only unique sets. Unique
List,
tuples,
yeah.
and then converting back to the list.
Yeah.
Yeah, Nandini, that's a nice approach. So the only thing is, if instead of result as a list, can you add that? Can you make that as a set, and then while adding in your while
Okay,
appending
here
list, no, like in this set, like in a result set over here, over in line 6 only, like you have initialized that as a set.
no, you can't modify the. Okay, here you're saying to add it as a set.
And instead of making that as a list, you can add as a tuple, and tuple can be changed or add or append.
No, we can modify the tuple, right?
But we can modify
Tuples are immutable,
Python,
right?
yeah, lists are
Tuples are
mutable, but
immutable.
tuples are.
So I think if we
so if we can add as a list in a set, we can't add that, correct?
List as a set.
I think we
List
can
in
do
a set.
something like this,
Yeah.
but we can't iterate it, right? Set. Something like this, right?
Oh,
Your
I
set
think
is
it boils down to same thing.
Yeah. But the code is very concise, and that I really liked about it.
yeah, that's a very
Correct.
very iterative and very
Yeah.
nicely done, I would say.
Yeah. But the
No,
time
I
complexity is slightly on the
have
higher side, correct?
yeah. No,
It will
when
be
I
n
just
square.
N square has to be very much less.
this will be outer for loop will be taking iterating all, right? And the inner loop will be like whatever elements I'm getting,
Yeah,
like
so
whatever
worst case it will be
subsets.
n square only.
Yeah.
I mean, initially you might have 2 elements, then 3, then 4. So in worst case, let's say if n, then n cross n, it will be.
I think it
For
would
the
be
last
more
element, it will
I am thinking like that.
So it's something like longest increasing subsequence, right? There we'll check keep some condition like maximum length, but here we have to generate all possible subsequences.
So I think it more than n squared, because in the inner loop, your results at increasing subsequence can be increased. Like we have given, if we are saying n is a numbers, so but in a result set we are making so many subsequences. At the most, we need to iterate all those subsequences
All those yeah.
So it would be more than n. Inside it would be more than n. Like in the words.
Yeah.
I mean, lengthwise it will be increasing, right? N will be more. Suppose outer for loop, if it takes n, let's take that it's 5 times or n. Like this will be.
But it cannot go more than the length of the array, input
Yeah.
array.
Yes. Yes.
if you look at line
I mean,
4,
all possible
I don't think it is
combinations,
I'm not sure, just thinking loud.
subsets.
Yeah.
I think it would go because in the inner loop we are saying that we need to iterate all the subsequence. So that's my concern, that inside, for example, here we have 4 elements, and in the list we have created, how about as she has created around 7 or 8 elements till we reach the last outer loop, last index.
Yeah, I'm
that
getting
would
that.
be
Yeah.
So
more
if we like if we think that this is 5 times the actual n, uh,
so yeah,
I'm not sure. I'm just
Yeah, it'll be more. Yeah, it'll be 2 raised to n, I would say. Yeah,
like
Yeah,
5
because
yeah.
it's
and
like
something.
yeah. So it'll be n into 2 raised to n in this case, correct? The whole big O.
why 2?
Yeah, I didn't
So because if 4, 6, 7, if you keep on adding that first in the last level, it will be 4, 6, 7 separate elements. Along with that, you'll have 4, 6, 4, 7, 4, 7, like in the second level, third level, and then go to the fourth level. So it will be complete tree, right? So the tree, if it's a complete tree, will have 2 raised to n nodes, correct?
Yeah, at
It's
every level.
all the subset of so 2 raised to n.
What we looked before is kind of like DFS, then this is kind of like BFS.
Yeah.
Yeah, so we are going each level, I think, maybe kind of, yeah, I don't know.
Right.
Yeah, that's true.
Hey, Kranti, you have something? He has raised his hand.
So this is a
Yeah.
complexity wise it would be same, but that's a nice approach, I would say, Nandini. And like if someone is not good in recursion or backtracking, sometimes it is good to have this kind of a solution.
I would think of this only first because I would never go
Yeah.
the recursive way. Yeah.
Yeah,
But it's
man.
not an easy to come up with, I would say. This is also not so easy.
Yeah.
Yeah,
It is
that's true.
intuitive bit, yeah, compared
It's
to
slight
the.
intuitive, yeah.
Yeah.
Yeah, good. I like this also. Yeah, Kranti, go ahead. Yeah, you have something to say?
Yeah, Nandini, please share the code.
So I need to share the code.
You share the code in the
Yeah.
Discord. Yeah.
Okay,
Yeah.
okay, sure.
No. I mean, share the screen.
Oh, he wants
Okay.
to, he has some question on it.
Yeah.
Yeah.
So, I mean, every time you are adding the largest value at n and you are checking the largest value only. I mean, you are not iterating
Yeah,
the
I'm not.
whole array. So
Yes.
then how it will goes to, I mean, inner loop, how it will goes to greater than out of n. I mean, I'm just asking the question. I have a doubt. Is
So
this
at
my question is clear?
so you're telling something like you're only checking the last element, right?
Yes. And
No,
we
we
are
are
just
invoking
adding.
the
We are
array.
adding.
Yeah,
See,
but you are
initially.
still iterating through each and every element of that res,
Yes,
correct?
yes.
Even if you are just checking the last element of that res for each and every index, but we still have to go through the each and every element of that res.
Okay.
That is the reason it is coming to restaurant. But yeah, you are right. We are just checking only the last element, and if we find that is greater than, then only we add it.
Yeah.
Yeah.
Yeah. Thank you.
Yeah. Good. Thank you. Yeah. Yeah. I think B was had something, but he left. It seems. Yeah. Okay. Then
Yeah,
Shashank.
sorry. It's I have just updated my name. It's Abhijit.
Okay. Yeah. Okay. Go ahead. Yeah.
Yeah. So it's very similar to the current approach, but it's just I tried to do bit of pre-processing, so that means so we can bit of damage. Look like we have this original array. Are you able to see? Okay.
Yeah.
And
We are able to
yeah.
see. Yeah.
And initially I just kept an integer. This is another process pre-processing array which I created to get the index on the left, which is greater than equal, which is lesser than equal to the current element. For 7, the least index which is lesser than the current element is like 2, and for similarly for this 7 it's 1, for this is 0, and there is no such limit, then it's -1 I have put. And starting from the leftmost element, initially there will be another two-dimensional array. The first element is empty because we want at least length of 2. And then while going to the, we iterate from the left to right. So like 0, 0, we take all the elements from the left which are lesser than 0, like -1, and then keep on adding it. Like here it's empty array, so it's just 4 would be appended with 6, 4, 6. Similarly, like 7, 1, we have to iterate over 0 and -1 both. Then we have 4, 7, 6, 7, and also this 4, 6 we already have. Then it's 4, 6, 7.
But
similarly,
array won't be always sorted, right?
Array means this array is always would be in the sorted order. Means it would be the preprocessing when we are checking any element, like then from the left, it's for every element we check all the element to its left, and if they are lesser than the current value of in the processed array, then in the second array, the array two-dimensional array, we check all the values and append it to them. Like 4, 7, 6, 7, 4, 6, 7. If we check 2, this one is also smaller than 2, 1 is smaller than 2, then 4, 7 would append 7, 6, 7 would append 7, and 4, 6, 7 would append 7. So it would be like.
So it would be better if you take complex, like after 7 also, if we have some elements like 3 and 4 again, like 7, 7, and then
3, 4.
3, maybe 4, then it makes sense to explain, I guess, because we have both increasing and decreasing, right?
Yeah. So like 3, there won't be any thing lesser in the left, so it could be -1, and 4, the lowest index, which is smaller than or equal to is 0. Okay.
So you're checking the previous element, like for 4, you're checking, comparing it with the 3, and
no, I was checking the smallest index in the left, which is lesser than and equal to the current element.
So you're checking, comparing 3 with 4, right?
No, sorry. It should be 2, 3, 4. Yeah, it should be 4.
No, 4 should be 0. 4 should be 0 actually. That is correct, because he is actually pre-processing and keeping indexes at that location for those elements which are actually lesser than it, lesser than or equal to. You know, so he just has to go there and jump and then start looking for the previous ones.
So how it is 0, 4?
So all the previous elements, or the just next previous element?
So now see, in this case, when he comes to 3, okay, he looks for which is the least of all of them. Okay. So there is nothing least because 3 is the least. So he'll keep it -1 there. So he doesn't have to go anywhere, go ahead in that. So for the 4, the one which is on the F column, when he has 4, he looks which is less than or equal to, in that case, the 0th index, okay, which has 4. So he can actually go and compare with that 4, right? So that makes sense, yeah. So, but I'm not getting it, but how do you, when you actually form these subsets, how do you take care of these 3 and 4? That will be slightly tricky to do. Right?
Yeah.
Because you are actually trying to append it, right?
So
I'm not saying that it won't be possible, but I'm just thinking it might be slightly
some
trickier.
extra conditions.
Yeah.
Yeah, some extra condition. Yeah, that's means edge cases we need to take care of.
Right. So he's trying to make some pre-processing. So he would try to avoid the 2n what you are doing, Nandini, in your case. To some extent, maybe it won't be completely avoided, but to some extent it might help. That is some optimization is trying to make.
He's taking care of sorting using the indexes.
Right.
Yeah. Index is playing something like some more modifications.
Yeah.
Then but it's a nice idea. Like I mean,
yeah.
In the index.
Yeah, means we can think of these edge cases. Yeah.
Yeah. So when the indexes are, I mean, this second row elements like -101, whenever we get something greater, we can just append. If we don't get, then in those situations only we have to compare the actual elements, I guess.
Yeah. Means like zero, we have to compare with all the elements in the left which are smaller than this zero. Like one, we have to all elements. We have to check 0 and -1. We have to consider these list.
Right,
Yeah,
right.
yeah.
For 2, we have to consider these all list. For 0, we have to consider only this
The
list.
fourth one.
Yeah.
No,
Yeah.
the fourth one. Yeah. A column. You'll have to consider in the A column. Yeah.
Yeah.
I think then, yeah, that should be fine, right? Okay. If you go to 3, you have -1, so you don't have to compare with anything. It will be just empty. And so 3 will be just your element there. Okay. But you don't want to take it because it's lesser than 2. Then you go to 4. Okay. Then you go to the A column and there you don't have anything. So you can add that 4 along with this 4. Right.
Yeah.
So you can start a new list for the 3 and 4, whichever the elements which are lesser than the previous ones. Right. And then you have to go to that column and then use those subset.
But again, for placing the index is checking, traversing the array, right? For which is minimum.
So then what happens if we have 8 coming up? So are we going to just stop at 3 and 4 or we are going to go for the 7, right? That will be again a dilemma there.
Yeah, if let's 8 come, then we should consider all of them, the smallest. Yeah.
So you have to consider 4, 3 also, right? As well as you have to consider 7. So then how to handle that case might be something to think of.
Yeah, means we have to think more about that.
Right. Okay. Maybe you can append both of them in that subset. But then again, if somewhere after 8, again you go to 1, okay, and then come again at 9. So then it will keep on increasing, right? The exponential.
Yeah. Same problem.
Right. Yeah. Yeah, but there are a lot of things. Maybe something to do with the caching. If we are able to cache that, then maybe those things can optimize it, and then you can get some better results. Yeah, but that was a good approach, I would say. Yeah. No problem. Shashank?
Yeah, we can.
Is he mute? Yeah, sorry.
No, yeah.
Oh, you didn't want to share your code?
Okay, yeah, mine is like here. Those two methods were there, but here what I saw in one of the discussion, they are using the graphs actually. Yeah, so depending on the increasing sequence, like if 4 is greater than 6, then 6 is greater than 4, then they will produce an edge from 4 to 6. And if 6 is greater than 7, again from 6 to 7, they will have an edge. So this is like the construction of the graph that it is being done here.
Okay.
I mean, adjacency list will get out.
Right.
Yeah. And then, go ahead. And then on that graph, we are running the DFS, iterative DFS.
Okay. So you're starting from the 0th index of a DFS for starting node and going through each and every level.
Yeah.
And then you again backtrack and then again you go for each and every level again, right?
Yeah. And these are conditions like, I mean, in stack, it should be only greater than 2, then only I'll accept it. Because at least 2 is required, right? Yeah. So like this is the iterative DFS part, this one.
Yeah, so that you're using stack.
Yeah. And for every, I mean, just going through the adjacency list, like for that neighbors corresponding to that node, we'll have some neighbors. So we'll be running DFS on all the neighbors and just copying it. It's a backtracking only by making the graph explicitly.
Correct.
Yeah,
this is a good one. Yeah, please share this code in Discord.
Yeah, sure.
Yeah, thank you.
We can switch to next then.
Sure.
So this is our Zuma game. What is it? You have a row of balls on the table, which are red, yellow, blue, green, and white. and you have also several balls in your hand. Each time you may choose a ball in your hand and insert it into the row, including the leftmost and the rightmost place. Okay, and if there is a group of 3 or more balls which are of same color touching, then remove these balls and keep doing till no more balls can be removed. So here, like if we can see, if there is a group of 3 or more balls which are touching, right? For the minimal balls, you have to insert to remove. So, but why are they removing here? White, red, blue, and white.
So they are inserting one from that hand string, and then they're removing.
Oh, and then
two,
checking if it is repetitive 3 or not, right?
continuous.
Yeah. Oh, so we are appending red here and checking if it is 3. Then we'll remove all these things, and it will be like white BBW. And again, we are putting B from our hand. Again, this 3 is becoming, so we are doing WW. But now no more balls are left in our hand. So this would be your like, find the minimal balls you have to insert to remove all the balls on the table. But we couldn't remove it. We couldn't remove all the balls. So the answer will be -1. Similarly, if we go, so this is our initial ball. So first white we are using. So if we are using white, there is first red they are using. So these 3 are becoming similar. So they are removing this. Now this is the remaining one. Then they are using the blue ball. Again, these 3 repeating. So they are getting this. And now once we have 3 or more consecutive, remove these balls. So you can remove these balls and it will be empty. So by taking two balls only, they are doing these things. And then so on. Hmm. Yeah.
Like when we are inserting any ball, that's kind of a one operation we are doing.
Pardon?
Whenever we are inserting any ball,
Okay.
that operation we are doing. For example, in example 2, we are adding R. So that's one operation. And next is when we are adding B, that's another operation.
Yeah.
And rest we are not adding anything, so that's why its answer is 2.
Yeah, after that it's because it's 3 and more are consecutive, so we are kicking off entire thing.
Yes, so we need to return that count, like where we like minimum count where we add where we
So
added
here
inserted.
actually we are adding 2 balls, red and blue. That's why the answer is 2.
That's why we need to. So where we need to check that how many. What's the answer? What's the minimum steps we have done? So when we
Minimum
are
step.
when we are inserting anything in our string, that's one operation which we are doing, or I
Yeah,
would say
right.
that's one. That's one count we are doing.
Yeah, but I didn't understand in example 2, when we still have an in hand, we have W, the first one. So why didn't we add a W, okay, in our list when we had 2 Ws initially?
So
Why we
why?
had to go to RR?
Yeah, because that would give it more steps. If,
Yeah.
for
Yeah,
example,
exactly. Yeah.
if it is adding W over here, that W that would W that's a one step. Then it would add R. Then it's a second step. Then it would add B. That's a third step. Then it would again add B W
Okay,
because
In the
so
question they asked minimum. That's why.
it starts
okay.
minimum, so that's why it starts from the R.
Mhm.
Mm.
So you could do it, you could still do it, but it's not the optimum solution.
Yes.
More number of balls you'll have to use in that
Okay,
case.
got it.
Yeah.
So that's a tricky one where to start from.
Okay. So in that case, okay, do you have any constraints in this?
Constraints are like initial row of balls on the table won't have any 3 or more consecutive balls. Okay, yeah. I mean, initially you won't be having 3 or more consecutive balls with same color.
In the text.
Okay, so you'll have only 2.
Yeah, they will.
2. And both the input strings will be non-empty. Yeah.
Okay.
Okay, so in that case, if it's like a optimal solution, so I can think of going the BFS approach, right? Because
Yeah,
you're trying to
BF.
find the minimum path.
So how come Okay, yeah, minimum number, but it's not a minimum path, right? It's a minimum number of balls. Because if you look minimum path,
We won't have anything. See, when we have to have an optimum solution, it means we have to have. You should use the lesser number of balls in the hand, right?
yeah,
To
but
actually create that, make it empty.
so does
Yeah.
that
So
imply
how
the
do you
minimum
decide
path?
first where to start?
Yeah, so you'll have to start like a queue. You use a queue and you start for each and every one. But then when we come to the one which is the least, actually, that will stop.
No,
If you're saying
second
that
thing is
we'll
like,
explore all.
So you will be checking all possible combinations.
You start with all, okay, but when you come to as the level or traversal, right? When you come to at a level when you see everything can be emptied, so
then
then
it
you
can
can
be
return
DP
from that.
also. It
Yeah,
can
it
be
can be
DP
DP,
also.
yeah.
Multiple
I kind
choices
of
there when take the minimum out of it.
I kind
So
of get a greedy vibe from this question because, as we discussed, the first character which we should look to remove is that character which has the left and the right most closely spaced. The left index and the right index.
For the board you are talking.
yeah,
Yeah.
so
Okay.
So in the example two, I think I'll go for either R or B as the first character to be removed because
Yeah, that can be
uh,
done.
but what about example 3 then?
yeah, okay. Example three. So here we have one character, G, right?
Hmm.
So in this case, we'll have to put two characters. We don't have any other choice.
But
Okay,
in
so
exam,
this.
you can also put a W leftmost or rightmost. That even that is also like a greedy approach, right? Why
So
did
how
you?
about
Are you
example
talking about the second example?
Yeah, yeah. If you take greedy approach, we
No,
have
that is
W.
yeah, because the leftmost index of W is 0 and the rightmost is 7, right? So to remove the W's, I'll have to, that would be that would be a more cumbersome task rather than removing R error because they're closely spaced.
So you'll take the difference of indices, I mean distance between first
Yeah, the
occurrence of
left,
that letter and last, and then compare the
right?
distances. Like whichever is closer, you'll attack first. Okay.
Yeah,
Makes
we can have
sense.
multiple with the same. Then we can choose anyone like in this case R or B.
That's a brute force only, right? Like
I think that is
calculating.
No, greedy would not be a brute force. I think the BFS, the way I was saying, might be a brute
Actually,
force. I'm sorry, go ahead.
so if we can see the example 4,
Yeah. Oh, sorry. So here,
here also if we, as he said, that we can do here they add Y first, we can add B as well.
so I
no,
won't
but
add
here
B
the
because I'll go for Y first or R.
no
So
R and B both are having the same distance, right?
Sorry.
First R and last.
Right. I'll go for yeah. I'll go for Y. I missed the leftmost R.
Should take the distances and sort them, right?
Yeah.
And
Basically,
but again, you'll have to find no the what is the first occurrence of that letter and last occurrence
that
of it. That
that is a O of n traversal. That can be done.
so why
So
not
there
add the R
BST.
last R?
Sorry.
The last R, its distance would be small. Why not add the R in the last first?
Sorry, I didn't get you.
Harshit, it would be better if you take write on whiteboard and explain.
Yeah. Could you quickly do that? Take this example 4.
It's yeah. So can somebody tell me that example?
Yeah.
RB,
RB.
double Y,
Yeah.
double B,
Okay.
double R, and then B.
Double R.
B after
Okay.
it.
Let's. That's it.
Hand. Yeah, hand is your hand also you want.
No. Hand. Yeah. Give me hand also.
Hand is YR, BGB.
Sorry. Come again, please.
The YR,
YR.
B, GB. Yeah.
Okay.
Yeah.
So let's focus on a board string first. For R, the first index is 0 and the rightmost index is 4, 0, 1, 2, 3, 4, 5, 6, 7. 7, right?
Yeah.
So the difference would be 7.
6.
For
Sorry, 7.
B, it is
1 and 8.
1 and 8. So that is
It's 1 and
7.
6.
No, it is 1, 2, 3, 4, right?
Last B, we have B, right?
Oh, you want to take the last one? Okay.
Your last occurrence.
Yeah.
Then we have Y, which is
2,
2, 3.
3.
So that is 1. And that's it, right?
Yeah.
I don't understand how you are taking those indexes.
So I'm taking the leftmost index of each character and the rightmost index. So for R, the leftmost index is this, and the rightmost is this.
So here we can use the concept of binary search, right?
Okay. And for the
First
Yeah,
and
yeah.
last occurrence
okay.
and get the
But the
index.
character is not sorted.
That has, it's not sorted now.
Oh, sorry. Yeah.
Yeah. Okay, so as I was saying, so I'll start with my character which has the minimum difference. So in this case, the minimum difference, Y has the minimum difference. So I'll select this Y and I'll put it here. So after putting this Y here, I'll remove the 3 Y's and I'll have B, and
R,
RB.
B.
right?
Yeah.
One more. Yeah, this is okay. Yeah, so next we have R and B. So I get this sequence, so I'll anyway remove this. So next I'll have.
No, but you have to again update the upper RBY, right? The indexes.
Yeah,
No, you can subtract 3 because every time 3 characters will be deleted. So index overall the difference will be reduced by 3 only, right?
No, but you are assuming that Y will be the innermost or whatever the location is. It can be anywhere.
Yeah.
Right?
Yeah, because in this case the leftmost index of R was not disturbed.
Yeah.
So as Shashank was saying that I cannot subtract 3 simply.
Yeah.
Okay.
Yeah.
No problem. Yeah. So we assume that it is done. Okay. Then next. Yeah, that's fine. You will have to do it. Yeah.
So this, so as Santosh was saying that I'll update this thing, right?
Yeah.
Yeah, I would be doing that. Yeah, so here I can see that there are 3 B's, so I'll remove that first. Because, okay, I can update the array also. So R would be this 0, 0, 1, 2, 3, 4, 5. 5. This is 5.
So Harshit, I was not telling to subtract 3 from indexes, from the difference, like 7 you have the difference, right? From 7 if you subtract 3.
Okay.
Yeah,
7.
because only 3 characters you are deleting, no, according to the question.
In that 7 minus
7 minus 3 plus 1, like 5 it will be.
I think that will be issue in that case as well. In the index.
Yeah, because more than 3 also there can be.
Yeah.
Okay, go ahead.
Yeah, so for B we
1,
have
comma
this
6.
1 comma 6. So 5, right?
Yeah.
So I'll choose any of them. So here it's 3 B's. So I should be removing this first. So now it's getting a bit trivial because I'm already getting a 3 length continuous sequence. So I'll be deleting that only.
Yeah, makes sense.
After this, I'll be left with this. So after this would be,
So after indices, you'll be checking whether 3 or more characters are present, or before you'll be checking. I mean, after this.
I think that can be done either way. Like once I have removed for B, no, sorry, the way once I've removed for Y, I can check that thing, or I can check before the next iteration.
Yeah. So here you have both as 5 and 5, right? Minimum. So
Yeah,
you'll
I think
okay.
I should be
You
doing it
can
just
add,
after.
or you need not add
Sorry,
also, right?
No, first you will
yeah.
try
So
to evaluate it, right? If it's something,
I
you
think
have
I
those
should be
three.
doing it. I should be checking this just after removing one character. Like the moment I've removed
Yeah.
Y, I should be checking that only.
Yeah. One more extra.
Yeah,
Because
Check.
reevaluate that.
this technically should not be there in my board string, right?
Yeah. Yeah.
Yeah, it should be removed the moment it is formed.
So maybe like after we form indices and add a character, we can have one more check. Like after we remove some character, we can keep some while loop or something.
Right.
Yes. Before calculating the distance, we have to check again.
Yeah, if you have 3 continuous characters, then you just remove that thing.
Yeah, I think this is a very good option. Yeah, the app, which is very beautiful, I would say. Yeah.
I'm still in the process of coding this. I haven't completed this.
Are you sure about the algorithm? I'm not very confident.
And you can never be sure about greedy.
Yeah.
No. It looks like, will
I
it
don't know.
pass all the test cases?
I
I'll
think
have
he's
to see.
thinking loud. Yeah, yeah. So maybe, yeah, why not you try it? If it's
Yeah, I'll try.
possible, then yeah, just
I'd
share a Discord.
Yeah, it worked on all the examples. Maybe I'll try and I'll get back.
Okay, no problem.
Because in the discussion, I didn't see any greedy approach.
Sorry.
In the discussion, I did not see any greedy approach.
Oh, okay.
Yeah, there were DFS, something like that.
Yeah.
So I'll have to try to be sure of this.
Yeah, if it's done, you
How
just
do you get the intuition for BFS or DFS here?
I think
Shortest
Santosh
path,
was.
yes, but Santosh was filling.
Yeah, okay.
Minimum balls we have to get, no, so shortest path. But how, like, how does minimum balls give us the intuition of shortest path?
I don't know. I thought it could be a DP approach.
Yeah, DP could be because choices are there and minimum we have to take out of them.
Because here we don't have that adjacent structure, that neighboring node structure well defined to
Yeah,
take it as a graph.
so maybe in the BFS way, we could actually start from the first index, and then when we have first two consecutive balls, okay, you start with that. Okay, you take that as a initial element for the whole string with that index, and you start with the BFS. Okay, so you'll have to maintain a for loop, external for loop, which will run through each and every letter in that board. Okay, and then inside you'll have to have a BFS with that starting index, and in that starting index you always pick up any ball, okay, from the hand, and then you do complete that and just check if that is how much in number of things you get in, okay, how much steps, or maybe what you say, how many balls you require, and then you
But
keep on doing it and go to the end. If you get something minimum in the for loop, then you return that, but it will still be more doing it for each and every letter. But this is a brute force. I'm just thinking loud, I never tried that way.
But BFS you got because of shortest path, right? Thought.
Yeah.
But like, I mean, they are telling us for minimum balls. So from there, like, how come you derive that intuition that it will be shortest path? Because path is like going from one node to this another node, right?
Right.
Looks bit ambiguously.
It won't be. I would say if it won't be something like a BFS though. Okay, but only when you're coming for the optimum number of balls what you require from that hand. Okay, so therefore I was saying like this is the minimum number. So minimum number usually comes from the BFS, because if you just visualize this as a graph problem. So, but still, for each and every element or each and every ball, you will still have to go. You'll have to start fresh. For each and every time.
I was
So
thinking
for
of
that particular thing, it will be a BFS for a single instance. Sorry, go ahead.
I was thinking of a recursive approach, which is like much similar on the lines that you're sharing.
Mhm.
So at every step, like start, pick the character at index 0, try it out and see if and get an answer for this. Like if we first if we first remove the character at index 0, then how many like steps it takes. Then try for index 1, index 2, index so and so on. I mean, this was like the most brute force and intuitive way I could think of.
I think, Ronnie,
I think, yeah, what you say
it
makes
should be the
sense.
first index. It should be the first permutation.
Yeah, so you start with any index,
Yeah, I
you
mean,
start with any index,
We'll have
first
to,
or
yeah,
maybe first permutation, that should be fine.
right.
But
So
you'll have to go through, because you never know, because with the first also, there might be some ball at the end, or maybe the
right.
ball next to it, yeah.
right, that would work because a hand size is maximum 5. So 5 factorial. That would
No, but I
close that.
still think, but it'll also depend on the size of the string, like the board size. So I think which could go big.
Will it be factorial?
So the way I understood Ronnie's solution is that he was saying that in that hand string, he would start with any character in that string and then complete that hand array and maintain a count and do it for every permutation of hand.
No, not a hand, but of board.
Board, yeah.
I'll start with every character on the board, like character index 0, and try to remove it somehow by using any character from the hand. And I'll get an answer, then I'll store it somewhere, and then I'll try for index 1, then index 2, and index so on. So I think the time complexity in this will be, I think, n factorial, because at every step, like for index 0, we will be actually solving for n minus 1, basically n minus 3, a string of n minus 3 length, right? So, and we will be doing it for all the n characters. So, yeah.
N factorial is again n raised to the power n, which is, I don't think so you'll be able to pass in the lead code.
Yeah, I'm pretty sure it'll throw
Oh,
it.
this is a brute force,
I
right?
just
Okay.
Yeah, it's a brute force, yeah. So the way I was saying was not working out. So he just got up with this approach. And I think this makes more sense.
But n factorial is, I mean, yeah, makes sense, but time complexity wise, it's too much. Like,
Yeah, but actually you can do more optimization in that case, because when you look at it, every time you are not going to be successful, correct? So you can
yeah,
actually eliminate those cases very ahead of that, right? Based on what you have in hand, okay, and all those things. You can mix many combinations of that, and you have already visited them. You can store them, something like that, and then you could come up with a much more optimized
yeah.
solution also. Yeah. Just thinking loud again, huh, Ronnie. I'm not saying
Yeah.
it. Yeah. Yeah. Sorry. Who was it Nandini or sorry?
If somebody was presenting.
Yeah. I'm sorry. I just stopped them.
I have one more approach.
Uh-huh.
So in this we have okay.
I think can we? Yeah, Harshi, you could discuss, but I think someone has
Alright.
implemented this.
Yeah, we can go for that first.
Yeah, please, actually. Because looking at the time constraints, almost 10:23.
Yeah, it's already to be 11.
I think Shashank, you had one, right? Who has
Yeah, but
Ronnie?
like I don't have full understanding of it. I can
Okay.
share you. They're using DFS, but I couldn't get the intuition behind it. This one, wait, I'll share it. Sorry.
Yeah, even I
Yeah,
was the same thing. It's
this is what I took it, but I myself couldn't follow this one. So actually, what they are doing is they are calculating a dictionary out of the hand, like how many which letters are present. Okay, like
Okay.
if this is your hand, so R is one, B is one. They are passing, so they are passing this board and the frequency of all the characters present in your hand. Now it goes in inside the DFS function and rest it initializes with infinity. After that, what they are going through every character of the board, and while going through every character of the board, they are checking whether board of J and board of I, if they are equal or not. And how? Oh yeah, I mean consecutive characters are equal or not.
Just
And if
checking
it
for
is
duplicates, yeah.
yeah duplicates, then they are increasing. I mean like J plus one, they are increasing the indices by that, and they are measuring the indices like from which point to which point they are consecutive, right? J minus
Yeah.
I. Like let's say when you inserted R, so it's consecutive from 1 2 3, 1 2 3, right?
Yeah.
So length will be J minus I. So this is the length they are calculating. They calculated, but again this line what they are saying,
They're
like
checking on the board, right? Before adding and character.
pardon.
So before inserting R, they are checking what is the length.
Yeah,
That's yeah.
but this line like length of the substring to be removed. This one I didn't get, like how they are doing this. 3 for 3 the frequency is 0.
I think
How
it
does this work? Like, what is
So
this?
yeah, 3 is 0 because you have 3 characters, then the
right.
frequency will be 0, right?
That zero means that you need zero more hands, more characters in order to remove that substring. I
Yeah.
think.
Right. And then you just look at it, what is the minimum of that one, 3 and length. And if it matches with that, then your need will be that value, right?
Satisfied.
Yeah. And then you look
So
for
what
that
are
in
the
your,
keys here? Like 3, 2, 1 with
Yeah,
some map is there, right?
yeah. The length of the substring to be removed. That is the comment they have written.
Right. So let's say the length is 2. That means that you need one more string, one more character
Okay.
in order to complete the length 2, 3, and then you can remove that that substring of length 3, right?
Okay,
So
this is like this map is constant, right? It won't be changed.
right.
Yeah,
yeah,
they
it
fix
won't.
it.
Yeah. Mhm.
But when we get some four or I mean, they're saying 3 or more, right? In that case, what happens?
No, we always look for more than equal to
3.
3, right?
Yeah.
So yeah. So in case it's 4, then it's also taking minimum of 3 and 4, right? So it'll be 3. So it'll pick 0.
Okay, yeah. So then you just go in that your collection or the dictionary and look at for the value need. If you are able to
Mm,
find it, right, and then you go and construct that rest.
okay.
Yeah. And yeah.
Yeah. Yeah, this is good, right?
And here we are comparing, yeah. And then we are subsequently we are
Removing and
I mean
calling recursively again, right?
for the next
Yeah,
next yeah. Till I
yeah.
we are avoiding, and after yeah.
So the way evaluation we were discussing with Harshit's approach,
Yeah,
that is
Yeah,
what is
same.
somewhat
doing in the
similar.
recursive way.
Yeah,
Exactly.
similar.
Yeah, so it is a combination of what Ronnie was saying and what Harshit was
Shit.
saying, right? Both of them.
Yeah, yeah.
Yeah.
I was not getting that part 15 itself. Like
Yeah.
more.
So Harshit, you might have to implement some recursive way for evaluating it, right?
Yeah, his approach also has, right?
Yeah, but he is
Okay.
not come up with whether it's an iterative or it's a recursive. Yeah, just thinking loud. So maybe, yeah. It could be done iterative also.
Yeah, maybe.
But I mean, it's again like coming this way is bit.
No, it's not so easy. But at least
Yeah.
what we would come with what Ronnie was saying, but Harshit's way was slightly one explaining on a whiteboard would be fine, but implementing would be the way Ronnie was saying, I would say the max case. Like the extreme case, I would think of doing it maybe with some more errors and all that, come to some conclusion, but not a fully implemented way for each and every test case.
Yeah, it won't. Right.
Yeah, it will take more efforts, not in a time of 45 minutes.
Yeah. At least to certain extent.
Right. Yeah, with that type of pressure, no.
Exactly.
Yeah. But at least it's good to go through this approach and do it on our own. So next time if something comes up, a similar one, we are slightly well prepared, I would say.
We can go through. Yeah.
Yeah. Yeah, but
So
that's
overall
that was. Mhm.
time complexity should be what? 2 while loops we are running. While inside while, so n square there, and on the top of that recursion is there.
Is it not O of n in this case?
No, while loop is there on the top, 10, line 10.
Yeah, but that is actually, see, it's a j. That index is just going from 0 to
0
length
itself.
of board, right?
Yeah.
And inside also you are just carrying on with that index. You are not actually doing anything more. When you go in that recursion, are you not shortening the board size?
Yeah, that is
Because you are
getting
removing
out
that,
of.
right? Yeah.
Yeah. Slicing operation. Yeah.
Yeah. So yeah, okay, but it won't be O of n
Quarter of
because
n.
you are going for it. You'll go for recursion, right? So it will be O n
Yeah.
square.
Well, yeah, looks like that only. I mean, O of n in recursion is not digested like. Yeah.
So it will be n square.
N square.
Right?
Yeah.
This was indeed a very hard
It should
question.
be
Yeah.
NQ.
Will it be NQ?
NQ, no.
We have two loops here, and one is the recursive one.
The second loop is just to actually, go through those which are duplicates one. So like when
First
we
will
have
go.
RR, yeah,
Yeah.
it's only the first loop which is more important.
No, but again, internally we are checking also.
No, but we won't go even if they are more, right? If it's all like GGG, the last example, right? You still go to the end, but it will be O of one in that case. When you are actually going through and covering up all the duplicates, you are just moving ahead with the same
Yeah.
index. So that cannot be considered a separate while loop in a while loop. It's not a nested while loop.
So when the outer j reaches the length of the last character, I mean, board's last character, and again you will be checking which all are duplicates. But yeah, j is increasing.
Yeah, if you go to the end, you are not going to go inside at all.
Exactly. Yeah.
Yeah.
But again, recursion is there.
So therefore, it's a recursion. Therefore, I'm saying it will be n square.
N square could be. Yeah.
I think in Python, the string slicing operation, I think it's ON in itself as well, because Python strings are immutable, I think. So it takes ON time to build the string as well on line number 26.
Yeah.
Yeah, internally it will take. Yeah.
So internally it will take ON as well, I think.
Yeah.
Yeah. No problem.
Yeah.
So let us see if anyone comes up with a solution in the Discord.
At least we got.
Yeah.
I mean, we got some idea. Yeah.
Yeah. Okay, then
Yeah,
let's
yeah,
call
yeah.
out for today. Yeah.